Words coming up. Right, I've got it. Question 1 was normalization.
Okay,
Question 2 was a digital neural network. Question 3 coming up was McCulloch and Pitts, all good stuff. And question 4 was texture co-occurrence. Right, guys. What's texture occurrence all about? Well, textures are tricky things to recognize. We recognize them as humans, but they have no specific features like corners or a face or whatever, and they are homogeneous. They occur throughout the whole of the image. So we can't look at a specific point in an image and say that information there is dependent on this texture because it's spread across the whole image. An image like this, let's try and draw something. Well, that's a rather thick pen. If I take an image like this, there's a sort of diagonal texture, and there is another texture there. Now that's very liney, very high frequency, but if you as a human were looking at that and you wanted the boundary between the two textures, there is the boundary. And looking at a single pixel, it's very difficult to tell whether we're in the texture 1 or texture 2. So the idea with a texture recognition is you have an operator which extracts multiple pixel information. And in the question, you are told to use a 4-pixel operator. And it was A, B, C, D, gets smaller. A, there is the center pixel, P, I, J. Here we have B. Here we have C. And here we have D. Now that is the information you're extracting is A, B, C, D, 4 bits. You could have a 9-pixel operator where I'm taking those into account, but that would be harder and more complicated for an exam. So I'm operating on the KISS principle, which is keep it simple. Right, so if this operator scans the image, I'll just draw it as a cross. There, I better write A, B, C, D there. B, C, D. That is going to scan the image, so it's sitting on every pixel, apart from the boundaries, because if the center is sitting on the boundaries, you're extracting information from outside the image. So we start off, we scan the operator, and the first texture is a checkerboard. Just draw a bit of it. Starts off, I can be bigger than that, I think. Naught cross, 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 naught. And clearly it's a black and white checkerboard high frequency image. Now if the operator is sitting, the first position it would sit on would be here. There's the center pixel. There's the pixel above, there's a pixel to the side, there's a pixel to the side, and there's a pixel down there. Now, looking at that information, the state the operator is looking at, A, B, C, D, cross is 1, dot is 0, will be A, B, C, D is 1, 1, 1, 1. If we now move the operator to the next pixel, so we're moving the whole thing over 1 pixel, it will be seeing 0, 0, 0, 0. And because it's binary and because I like to set simple questions so you can pass the exams, you should be able to deduce that whenever that operator is sitting on that checkerboard, it is going to give either all 1s or all 0s. So having got that information, the histogram, which is the TCS, is going to be a histogram just like the normalization histogram, but instead of being pixel information, it is the number of states under the operator. And so we will have the values of A, B, C, D down here. And it will be 0, 0, 0, 0. I'll write it out in binary because that's the information you're extracting, to 1, 1, 1, 1. Okay, and the vertical is the number of occurrences. And so for 0, 0, 0, we're going to get a pretty large number. I don't think you'll get any other occurrences except for 1, 1, 1, 1. So there is the histogram, and we've got all the values in between. So that represents the information about the texture. And from that, we can get a vector. And the vector is going to be, let's call it pattern X. It is going to have 16 dimensions, 16 elements. And the first one is going to be this, let's call this X0, and this will be X15. And it's going to be quite simply, however many occurrences of 0, 0, say there was 8 of them, it's going to be 8. All the rest are going to be zeros, right the way through to 8 there. So it is the 16 element vector with only 2 amplitudes in it. Repeat the same for the other texture. And looking at the exam question, without drawing it, you can see that now I will draw it for you. If the second texture is vertical lines, which is a less high frequency image than the checkerboard, that's a dot, cross, dot, dot, cross, dot, cross, dot, dot, cross, dot, cross, dot. That's enough to get started. Let's just tidy that up. That's supposed to be a dot in there. Now the operator sitting on that texture, let's draw it in black. It's going to be, there's the center pixel, there is A, there is B, there is C, there is D, and the information you're getting from that is going to be A, B, C, D. And it is going to be A is 1, B is 0, C is 0, D is 1. It's going to be 1, 0, 0, 1, or whatever you, did I label them that? A, B, C, D. There's the labeling. Make sure it's the same. A, B, C, D. Was it? Yes. A, B, C, D. A, B, C, D. 1, 0, 0, 1. Yes, great. Right. And as it moves over to the next position, it is going to be 0, 0, 0, 0. No, got that wrong. Got that wrong. Let's do it. Let's have blue in there. Next position is going to be there. So we're looking at that pixel, that pixel, that pixel, and that pixel. So it is going to be 1, 0, 1, 1, 0. So the second state is going to be 0, 1, 1, 0. And I think if you go through that image by inspection, you do a shortcut, those are the only 2 states that are going to occur. Get the TCS. And having got the TCS, you can get the vector, and let's call this Y for the second pattern. And that is going to be all elements at 0, 16 elements again, except for element 8, element 9, first one is for element 6. 6 is going to be 8, whatever. This is Y6. There's going to be noughts in the middle. And the other one is going to be Y11. No, Y9. And that is going to be 8 or whatever number it is. So we end up with another 16 element vector. Once you've got vectors, you can classify them. And the sort of techniques that use vectors as input, it could be an analog neural network, but that's quite hard. I've opted in that question for a distance classifier. Let's just move that up. Right, so we can use a distance classifier. And the first would be if the pattern 1, which I called X, is class 1, and y, vector y, is class 2. The checkerboard and the vertical lines. If we have an unknown pattern, measure, say z, and z could be whatever, 0, 1, 1, 2, 4, 7, another 16 elements. Using the Euclidean distance, Euclidean distance is simply Pythagoras, and it is, we would need to calculate dxz, which will be the unknown from the first class, and the equation used there is the summation I equals 1 to d over all dimensions, in this case 16. It will be xi minus yi squared, and you can take the square root if you want to or not. It will still give you the right answer. If you get these round the wrong way, yi minus xi, it still works because we are squaring the operation. And so that would be the Euclidean distance classifier. And then we come to the approximate distances. And we're now moved away from the texture classification to describing distance classifiers. And the approximate distance, you have a choice, either the city block, and the city block is the summation I equals 1 to d of, instead of squaring that occurs in the Euclidean, we take the modulus, and they're both monotonic, so they both will work. And so we take ai, was it ai, xi, xi minus zi, all dimensions, and we don't square it. Come on. We don't square it, we use the mod operation. And that is simply an addition, or in this case, a subtraction, and ignoring the sign bit. So a lot easier, a lot quicker to calculate if you were applying this to multi-million megapixel images rather than the ones in the question, which are, I think, 5 by 5 bits. So that would be the city block, or you could use the square distance. And the square distance is the maximum operator. You're looking for the maximum, I equals 1 to d, so for all dimensions of the mod of xi minus zi for each reference class. Now they are very different operators, but geometrically they are the same or similar, because the city block will give equidistance contours, and if I've got 2 dimensions and I've got a point in 2-dimensional space, the city block contour has a equidistance contour which is a rhombus on the side. The square distance will have in 2 dimensions, we can only easily draw 2 dimensions, will have a contour of equidis, which is a square in 2-dimensional space. And the Euclidean is, of course, a circle, a point in 2-dimensional space. All the points, a unit distance from that point, will be on a circle. And if you put them all together on one diagram, if I can draw this quickly and accurately, if we take the point and the Euclidean, it's going to be a circle. Can't draw it really very well. If I take the square distance, it is going to be a square which touches the circle. Whoops. And if I take the city block, it is a diagonal which is inside the circle. And we see, if I've drawn this correctly or clearly, all these points would be the same. So these are all the same. But if I move to a different point here, if we take the example there, this point by the city block, this point by the Euclidean, and this point by the square distance, they, according to those approximate calculations, will be the same point in two-dimensional space, a distance of 1 from the center. And clearly that's not true. So these are of course causing errors. So a bit of discussion at the end. Oh yes, I think I've gone further than what's required in that question. You just, yeah, don't need to compare them. Part D, how can texture recognition be used to find boundaries between different textures which could not be found using Sobel, for example? Go back to my original diagram. There it is, which are the two textures there. We want to find that, let's draw it slightly again so it's not so cluttered. Right, we've got our texture there, and we've got our texture there. It could be a clothing pattern or some texture and whatever, metal shapes or whatever. There is the boundary. This is the boundary we want to detect, the edge between the two. Use a texture operator to train on this texture. So this would be texture 1, so call that pattern X. Use another texture operator to train on pattern Y. This is the Y region, train on Y. Then you apply the operator to extract information from the whole image as take a second image if you like, which will be slightly different. Remember, no two images are the same. Scan the image, compare it to the distance between the trained X. Clearly in this region is going to be the X texture, and the Y texture is going to give 0 response. So you will get a response of high and then going down as you go across. And then clearly when you cross this boundary, you will get the other distance becoming closer. And so you'll get a response, which is going to be there, the second one detecting it. And that change will occur on that boundary. And you can deduce the boundary from those recognition measurements. So that would be impossible to do with a Sobel or Roberts or Pruitt, which are basically the same. It would be extremely tricky to do with a Canny or a better quality edge detector. But perceptually, if you're looking at that image and I say, where are the boundaries? Yes, I can't give you, I have to draw an artificial image, but real images, you can imagine them. There is that, there is that. As a human being, if that was very tightly vertically and that was horizontally, you as a human would perceive that being the boundary. And this was a PhD project some time ago, and we really got an amazing result from using this technique on real images. We took a surface which was grass, a very strange texture. Look out the window on some grass on the lawn, and it looks pretty chaotic. And what we did is we took a window of that image and we rotated it 90 degrees. And looking at it as a human, you could just perceive in this composite image with the center rotated 90 degrees, a slight change in difference in texture. And using this texture co-occurrence method to recognize the outside, which is the normal, and the center, which is the rotated, we were able to interpret the boundary pretty accurately. And there was no conventional edge detector that even touched that. So scaling it up, it was quite an impressive result. And that's gone way beyond what I expect you to answer on that question. So basically the principles, the TCS, the The TCS is a histogram that gives rise to a vector, and then you use vector methods to classify the data. Boom, boom. Any questions? Silence.
Hello, can you hear me? Hello?
Hello, yes, I'm still there.
Hi. I just wanted to ask for this type of question, as we're using our student ID numbers for a question which has, like, for example, images based on bits, ones and zero,
Yeah.
how would that be approached using our specific ID number?
Gosh. Yeah, I don't want to give too much away here.
Apologies. All right.
There might be less, if this were to come up, there might be less emphasis on applying it to a specific example, because I can't generate a specific texture from your student number, which will give you a simple result. But with other applications, normalization, for example, supposing you were dealing with a 4x4 image. Now, last year, I would give you the image in 4 bits per pixel. And last year, the question might have been, oh, this might be 4, 4, 5, 6, 3, 7, 8, 9, 8, 9, 10, 11, 9, 10, 11, 12. Now, if those were the intensities and you were asked to normalize that, the darkest is 4, so 4 goes to 0, and the brightest, the whitest is 12. 12 has got to go to W, and you do that by a shift and add. That was last year or previous years. If this comes up this year, I might tell you to take a 4x4, take your student number, supposing your student number was 1974216. You might be told to scan it vertically in your 4x4 window, starting with your first number. So you would end up with a 4x4 image based on this number. If you're told to scan it vertically, it might be 1974216. There's your number. Then start repeating it again. 1974216, and carry on 19. Okay, it gives you an image. It can be normalized because the lowest is 1, 1 goes to 0, and the highest is 9, 9 goes to W. But of course, each of you will be using exactly the same techniques, but a different data source. Okay?
Yeah, that's perfect. Thank you very much.
Any other questions, guys? Anybody left?
One of my classmates, Adam, says if you could go through 2019, question 1.
2019, let me try and find it.
I think it's Pitts and McCulloch.
Right. Just hang on, bear with me a moment. I'm looking at right on the other machine.
He's saying that his issue is mainly on part C.
Yeah, just hang on.
Yeah, that's fine.
There it is. Question 1, what is the linear separability in data? Is that the one?
Yeah, I believe that that's the one. I think you need to
Right,
go
okay,
through
going down.
question 2.
If after training the inputs are, yes, explain quadric machine. Is it the multi-layer perceptron comprising 3 neurons? Is it that part?
The third part, which says if after training the input neurons have the following weight vectors, and then it puts.
Yeah, I've got it. I've got it. Great,
Yep.
great. Right. Right. So this is 2019 part 1C. Right, you have to get the diagram of the multi-layer perceptron, and it is 3 neurons. So the basic diagram is 1, 2, 3 neurons. We have A and B coming in here. They go to there, they go to there, they go to there, and that is the output. So that is the diagram at the neuron level. Now to get the details, let's call this 1, 2, and 3. That's the way I've labeled them. Yes, 2 and 3. The detailed diagram is going to be A and B coming in. For neuron 1, we have 2 weights, W1, W2. They go into a summer. We also have the bias, which goes through a 3rd weight, and that is a constant, usually 1. And they will go through a threshold. And there is the output. So that whole thing is the equivalent of node 1. Now for node 2, we have another pair of weights. They go into a summation. And A and B are connected to there and there. Again, a weight for the bias. And the bias input is 1. They go through the threshold. The threshold T is 0, I think, so we're looking for either positive or negative. And they produce an output which goes into the 3rd neuron, which is this one here. And we will have 2 more weights, W1, W2. They go into a summer. And we have a bias on the 3rd one. That is W3 with a constant input, and then finally the threshold on the output. So that is the full diagram, right? And we are told that W1, the weight vector here, is W1 is equal to 3 minus 2 minus 2. The weight vector here is W2, which is minus 2, 3, and the bias is minus 2. So this will be minus 2, 3, and minus 2 in there. And for the last weight vector, we have W3 is going to be equal to 2, 2, minus 1. Right. We can now work out, shrink this down a little bit so I can keep on the same page. We now have to work out how the, yes, we're applying all 4 inputs, and we want to find out what logic function occurs. Okay, so the table, A, B, we are going to have 0, 0, 0, 1, 1, 0, and 1, 1. The bias for all the inputs certainly on the first layer, is going to be 1. So add the bias. And that is going to be 1 for all of them. That is the fixed bias going in there. So we're dealing with the first neuron at the moment. Okay, the outputs of the first neuron. So we're looking at this point here. It is going to be the scalar product of this with the inputs. And so let's call this 1. It is going to be 0 times 3, 0 times 2, minus 2, minus 1 times 2 is going to be minus 2. For the next one, it's going to be minus 4. For the third one, it is going to be plus 1. And for the fourth one, it is going to be minus 1. Yes? Yeah, minus 1. All clear on that? Scalar product of the weight vector with these 3 element binary vectors. And after the threshold, if the threshold is 0, it is going to be 0, 0, 1, 0. Now for the second neuron, 2, exactly the same process, but we will be using this weight vector to get the information coming out here. And that is going to be the scalar of this with the inputs, which is going to be minus 2, 1, minus 4, and minus 1. And after thresholding, threshold t equals 0, is going to be 0, 1, 0, 0. Now, for the third threshold, this is the input, the output of the first neuron, which is there. That's the first input. That's the output of the second neuron. The bias is 1 again. So we now apply the third weight vector to 0, 0, and the bias will be 1. And that will be 0, 0, 1. It will be minus 1. For the second one, it's going to be 0, 1, 1. Bias is always 1. 0, 1, 1 is going to be plus 1. For the third one, it is going to be 1, 0, 1 with the bias. 1 times 2 is 2. Minus 1 is going to be plus 1. And for the last one, it is going to be 0, 0, minus 1. And that is going to be minus 1. And if I've not made a mistake, that is the output. So what logic function is, after threshold, this after threshold is going to be 0, 1, 1, 0. So after thresholding, the output, this is input A. This is input B. That's the final output. Looking at that, if I haven't made a mistake in the calculation, the function f is going to be, as a logic function, A exclusive or B. So it appears that the multi-layer perceptron is performing the XOR function, which is an interesting problem because you know the XOR function is linearly inseparable and a single neuron can't solve that. So now if you'd made a mistake in the arithmetic and the scalar product, you'd only lose a mark, and you can lose 6 marks and still get a grade A overall for each question. So the main thing is getting that method right, understanding that diagram, understanding what each neuron is doing, being able to calculate the outputs and feeding it through to the output neuron. Okay?
Clear.
Right, any other problems, guys?
I don't personally have any. Thank you.
Excellent. Well, do well in the exams, and remember, it's the methodology is the important thing. Yes, get the right answer if possible, but if you don't get the right answer, but you're using the right method, you'll still do pretty well. Okay, guys, anybody else? Are you
Um,
Ahmed I'm talking to?
Mohammed.
Yeah, I was in the process of writing an email before I came online to you, but have you got enough information now without me sending it? Because
Oh
I
no,
haven't finished.
it wasn't me that emailed. It probably must have been someone else.
Okay, fine. I'll carry on then.
Uh,
Right, guys, I'll hang
yeah.
around for a few minutes. If anybody has any questions, just ask.
All right.
Yes,
Thank you.
I
Bye-bye.
was the one you sent the email to, and I got all the information. Thank you so much for
You've
the
got it
reply.
all now. Okay, so I
Yes.
won't bother with finishing that email.
Oh,
Is it
okay.
making sense?
Yes, it makes sense.
Yeah.
Do you have any final piece of advice for all of us?
Well, Tatiana and I gave you a steer on the important topics in this particular exam and concentrate on them.
Okay, thank you.
The important topics for me were image processing and digital neurons. And I'm saying no more.
Fair enough.
If you, I mean, understand the whole syllabus. I mean, if you fail and have to retake, not that this will happen to you, I hope, but if anybody fails and retakes, the emphasis may well shift on the retake paper. So don't miss out on large chunks.
All right. And also one last question. For image processing questions, especially high pass and low pass filters, you said that the
Yes.
exam will have a 5x5 array. Is that correct? Is that the dimension that you will be using?
Yes, that's the smallest I can do because you lose the boundaries on an image. So a 5x5 will give you a 3x3 output. If I went down to a 4x4, it becomes very small, and 3x3 would only give you a 1 pixel output.
Okay.
So a 5x5 for filtering is pretty standard.
Okay.
For normalization, expect a 4x4 image.
All right. So for normalization, it will be 4x4.
Yeah.
For filtering, it will be 5x5.
Most probably.
Most probably. Okay. Thank you.
I mean, when you're applying the method, if you have to apply a method 3 times, 6 times, or even 9 times, it's reasonable. But if I gave you a 16x16 where you have to apply the method 200-300 iterations, that's silly. So the examples will be simple in the exams. But remember, these are scaled up to much bigger images. And in real life, you'd be dealing with millions of pixels rather than just 9 or 16. But the fundamentals can be shown on these small images. It's going to be fun. You're going to enjoy it. I hope.
I hope so too. Thank you so much.
It's just sad that we haven't been able to thrash these ideas out in person in the class this year, but there's nothing we can do about that now.
Sorry, Stonham, you said something previously that I didn't quite catch. You were talking about if you do feel like, obviously I don't intend to and everything, but what was it that you were talking about, referring to?
No, I said we have given to be helpful because of this personal generation of data. There's more time to be spent on sorting out the questions. So we're giving you only 4 questions this year, and we've told you that they will be, the emphasis on those questions will be on image processing and the digital neural networks. Now, if you have to retake the exam, it will be a new exam, and there will be a different emphasis. It could be analog neural networks. It could be distance classifiers. Okay.
Yeah, I see.
At this stage, as you saw with the texture analysis, which is a digital technique, distance classifiers came into that. So don't ignore any parts of the course, but make sure that you have the fundamentals of image processing and digital neural networks this time round.
Sure. Thank you.
Okay. That's supposed to be a helpful piece of advice. And Tatiana has done the same on her topics. I can't remember exactly what they were, but we did give you that guidance.
I was clearly saying that what would be on exam. So, but in previous hour, I did mention go through practical questions. Make sure that you emphasize practical skills. So this is quite important.
Yeah. The main thing, guys, is when you are confronted with the question, don't panic. If you have any difficulty with generating your own patterns, in my case from the student number, tell me what you're doing. As long as you are operating on an image which is personal, if you've made a slight mistake in writing your student number down, supposing your number started with 19 and you put a 2 in, I'm not going to take any marks off of that. That's silly. That's just a means of generating a data for you to use. So don't panic. Tell us what you're doing. If you have any queries about interpreting the questions, say what your interpretation is, because we want to give you marks. We don't want to fail you. And we can't give any marks at all for blank papers. So tell us something about the material, and then we can give you some credit which matches your understanding, which I'm sure is not 0.
And make sure you show all your workout on the paper. Don't like sort of only put the answers without any workout, how you get these answers.
Yes, in this last question I've been through, I'm working out the function of what the multi-layer perceptron is doing, and you're told to find out the logic function. If somebody had made a stab at it and said the function is answer F equals A nor B, if you just submitted that as an answer, clearly you will get no questions at all because it's a guess. And even I think if you had the answer exclusive or without showing, I might have given you 1 mark for being a lucky person in guessing it, but you won't get any marks because you haven't showed how you've got there. And it could have been a guess. So that would be wrong. That would be 1 mark. And this would be, where is it, 10 marks. Okay. I think our hour's up by now.
John, you have a question from Adam. He doesn't understand how he gets output values for each neural in the table.
Right. Input pattern goes in on AB, so AB goes in there. The third bias input is there because you've got 3 inputs to that neuron. You then calculate, what the neuron is calculating is the summation. It is the summation of, over all dimensions, I equals 1 to D, of Wi, I. So that's the general formula you will see in the notes. W1 is the value there, W1, which is that value there. I1 is the input here, which will be A. So the first calculation you do is W1 times A, which is going to be 3. W1 times A is 0, times 0, plus summation. W2 is this weight here, which is -2, which will be -2, let's put brackets in there because of the minus sign, times input 2, which is going to be B, and input 2 is again 0, plus the third input, the bias, which is input 1, and the weight is given as -2, so it will be -2 times 1. And if we work that out, 3 times 0 is 0, 0, -2 times 1 is -2, and -2 is what I should have in that column. Yes, I have. I've got it right. -2 is the output there. It goes through a threshold, and t equals 0. What's that? T equals 1 there. That's the bias as being 1. T equals 0, and so it's negative, below 0, below the threshold, output 0. Negative 0, positive 1. So the output, and for the last one, I've lost my way now. Yes, there's the 4, 0, 0, 1, 0. -2 is 0, -4 is 0, +1 is 1, and hey, what's gone wrong there? -1, that's -1, yeah, sorry. My diagram's getting messy. But as I say, if you make a mistake in any of these columns because you've done the addition wrong, yeah, you might lose a mark. But the vast majority of the marks will be you convincing me that you know what to do to apply the data to A and B and work it through the two layers and getting the output. Okay, any other questions? I haven't got any chat up at the moment. You'll have to speak to me. Okay.
I don't think there's any other new question right now.
Okay. Well, it's coming up to Friday. Have a relaxing weekend. Don't work all the time. Do take some breaks because your efficiency fails after 10 hours of working. Have a break, go outside or do something, have a cup of coffee or whatever, and then get back to it refreshed. And don't try and memorize this stuff. Understand it, and it'll be simple. That is the big problem with neural networks. Millions of people in the world are using them, and they just don't know what they're doing. And they get results, and it doesn't work, and they haven't got a clue what to do then. The computer doesn't work. If you go back to the fundamentals, you might just get an understanding and an explanation as to what's going on, and that can lead to better systems. Okay, I've missed out on my breakfast. I think I'm going to see if I can find some. Any other questions? If not, I'm going. Okay, guys. The exam is, when is the exam, Tatiana? Forgotten. It's next Friday, is it? Tatiana, are you there?
It's next Thursday.
Next Thursday. Okay. So we won't have a Friday session before the exams. Anybody need any further help? Contact me by email and I'll try and get back to you within the day.
All right, thank you.
Okay, guys. Bye.
Bye-bye.
Ooh.
Thanks, John, for coming back so quickly.
Yeah, sorry, I messed up on logging in this morning.
No, it's all right, but you were very quickly getting in, so thank you for doing this.
Yeah.
It's all done.
Yeah, we won't have, obviously not have a session next Friday, but
No, there is nothing. It's the last session, so hopefully we will be doing well.
contact me by email or phone if there's any problems.
No, should be okay. I send you. We have 50 students in the list.
50.
Yep.
50. Gosh.
Yeah. And I never saw higher than how many? 24, 25 students in the class.
Mm.
And actually today it was quite few students I have never ever seen in the class, and I was not aware they are doing the module.
If they think they're going to set up an app group and try and do joint submissions, they're going to be disappointed, aren't they?
You can, like sort of they were today in the morning, they were asking me questions. I was covering several times, yeah, and some students who've been already in the classes, they say, oh, this was already covered, this has been covered, this has been covered. So obviously they even didn't go through the material.
The exam is 3 hours, isn't it?
Yeah, 3 hours and 30 minutes for upload.
Yeah.
And the ones which get in today, like for example, Kemi Ramid, I'm looking on the names, Adam Wilds, yeah, Muhammad Altair. I have not seen him. No, Alistan Gonzalez. I have not seen them, or I've seen them very little in the classes at all.
Those names have been in contact. Alison's been in contact with them by email, and Adam has as well.
Yeah, but they have not been attending. It's more they start to do, at least maybe like sort of they start to do preparations, and but it's like some students. I'm looking for attendance. We have several students, John, 0 attendance. We have quite few of them. I can tell you.
Maybe those are the brilliant ones who find this material so simple.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Twelve, 13, 14 students never attended at least one session.
Gosh.
In term 2. And 3 students attended 1 lecture.
I don't think I want to hear this, Tatiana.
We are speaking about potentially 17 students on the way for a seat. They never ever attend any lectures. What could you do?
Well, on my foundations assignments, a third of the class didn't submit.
Say it again.
On my foundations of engineering assignment that I sat a month or so ago, a third of the class did not make any submission at all.
Really?
Mm.
Did I told you my level 1 students?
Yeah, you said they were bad.
You had problems to pass them. And still I had some students, they fail, but they basically give me 0 material that I can pass them.
Mm. Well, we'll have to see what happens. We'll know by next Friday what they look like.
Yeah, I know. I'm going to set up. How do you want? I will set up rubrics for us to marking, question by question or by mini questions on.
Whatever. We're marking grades, aren't we? Not numbers this year.
Yeah, but I can set up by grades.
Let's talk about it when we meet up.
Yeah, I think I can set up later on as well. Yeah. So before we start to mark. Maybe it's better that we set up some sort of rubrics.
Yeah, I'll try and improve my my knowledge of marking techniques or facilities on WiseFlow. I don't want to go over what happened last year with me having offline notes all the time.
Yeah, take your Surface with you on Thursday, so we'll go.
Yeah, I'll bring it on Thursday. Okay, Tatiana, I'm going to have some breakfast.
Okay. Thank you. Enjoy your breakfast. Bye.
Yeah, thanks a lot. Bye for now.